Hello, everyone. Welcome back. I'm Adam Okada from Beyond Clean, and it has been such an incredible day of learning. Thank you all for being so engaged with the discussions we're having today, and keep those questions coming in. It's not often we get a chance to ask these burning industry questions to true experts in their fields, so definitely take advantage of that opportunity. If you see that Ask a Question section down there on your screen, I'm going to highlight it right now for you. That's where you can ask questions of the speakers, anything you can think of. Go ahead and just ask them a question, and we'll answer that in the Q&A. Any questions we don't get to, we will send to the speakers later so they can answer your questions offline. We do have a lot of conferences coming up, both virtual, and if you live in Massachusetts or California, then Beyond Clean is coming live to your area later in 2021, so stay tuned for that. It's my pleasure to reintroduce our next guest. If you didn't get a chance to hear our introduction earlier, Dr. Brian Kirk is the managing director of the Brian Kirk Sterilization Consultancy Group. He worked for over 10 years in the UK National Health Service as a quality control pharmacist for a hospital pharmaceutical sterile supply company, gaining qualified person status as a result of this experience. He joined 3M Healthcare in 1989 as a development scientist for sterilization products with a special responsibility for monitoring the development of national and European standards relating to sterilization. During his time with 3M, he's held a number of additional responsibilities, including European Technical Service for sterilization, supporting customers and business teams. Brian is also a member of a number of BSI, CEN, and ISO committees, responsible for developing standards for chemical and biological sterilization indicators and steam sterilization processes. Brian has presented at a number of national and international conferences and is a registered authorizing engineer for decontamination. So what do we truly know about that roll of tape that's sitting on our wrap stations? And why are the strengths of a tape's adhesion and its color change characteristics important to sterility? The answers to these important questions, as well as identifying the regulatory requirements for autoclave tape, will be discussed during this next Can't Miss session. Don't get caught in a sticky situation during your next regulatory visit. Let's learn everything we ever wanted to know about autoclave tape with Dr. Brian Kirk.
Well, thank you, Adam, for that kind introduction. And it's always nice to be able to present a sticky subject matter. That's enough of the corny jokes. Let's press on. Well, the title of my talk is, as Adam mentioned, everything you always wanted to know about autoclave tape, but were afraid to ask. Well, so I can hear you saying, how can somebody possibly fill an hour talking about simple old autoclave tape? And I think that's probably a legitimate question, but I'm hoping to prove that it is possible to speak at length about autoclave tape because it is quite an important technology to the sterile processing department. And actually, there are a lot of technical attributes which need to be considered when designing an autoclave tape and when indeed using it. So let's enter that wonderful world of autoclave tape and find out a little bit more. But first of all, I have to read some disclaimers. So what I will present today is based on both US and international standards and guidance. And it is important to follow the instructions for use of any product that you use in a sterile processing department. And if you use it outside of its standard claims, then it will in fact invalidate any liability that the manufacturer would have. Individuals must, of course, make their own purchasing decisions. So, as Adam mentioned, my name is Brian Kirk, and I'm the director of Brian Kirk Sterilization Consultancy Group. I set the company up in 2019 after leaving the 3M company after 30 years of service with them. And I've actually been in this field for over 40 years now. Long time. So this is my CV. I'll let you read that in your own time. Adam summarised it very nicely. So let's have a look at our learning objectives. Well, relatively straightforward. We need to identify what autoclave tape is and how it's used. describe what the standards state about using indicator tapes in general, explain how the adhesive properties of autoclave tape are measured, identify what is meant by bundle popping and how it can be tested. No, that's not a dance from the 1950s. Explain the colour change characteristics of the indicator ink on autoclave tape. So let's start off by looking at what autoclave tape is, although this may seem to most users obvious. So autoclave tape is a pressure-sensitive adhesive tape, which is used in the sterile processing department to secure the wrapping, also known as the sterile barrier system, together to ensure the maintenance of sterility of the packs that are produced. What we mean by a pressure-sensitive adhesive is that it will stick to surfaces when it is placed on that surface and then moderate downward pressure is applied. Pressure is usually applied by the palm or finger and thumb, and this should be sufficient to initiate the adhesion of the tape to the surface. It should be noted that once tape is adhered to a surface, it will go through a maturation process and generally become stronger as the glue migrates into the surface to be bonded. So the tape also has a steam sterilization process indicator printed on it, which is designed to change from a starting color to another very different or darker color when exposed to a steam sterilization process. I will talk more about what is meant by the term process indicator a little later on, but it should be obvious that the better the color change, the easier it will be for users to differentiate packs which have been processed and those which have not. And this, of course, is one of the important attributes and uses of autoclave tape. I should add at this point that there are other tapes for other sterilization processes available. So autoclave tape for steam sterilization is not unique. You can get indicator tapes for ethylene oxide or for hydrogen peroxide or for other sterilization processes that you might be using. So why do we need and use autoclave tape? Well, many reusable surgical instrument sets are wrapped in single-use or sometimes reusable flexible packaging, which are also called sterile barrier systems. So the purpose of autoclave tape is to secure the packs wrapped in these flexible materials to create a sterile barrier layer. With the presence of a process indicator, the tape provides not only a securing mechanism, but also an indicating mechanism as well. Now, in the early days of sterile processing, wraps would probably almost entirely be made from cotton fabrics, and these would be reusable. And so the adhesives that were originally designed would have an element of peelability associated with them, so that when you were laundering those reusable wraps, you could then peel the tape off. Of course, today many materials are used from single-use sterile barrier systems, and these can range from simple paper bags with a smooth surface, or crepe paper, which has an undulating crinkly surface. Non-woven materials are made from polymeric plastics such as polypropylene or polyethylene. And some of these have surface modifications which change their surface characteristics, and therefore the way in which any adhesive might interact with them. There are, of course, also some modern reusable wraps which are made from non-cotton materials. So in addition, autoclave tape is also used in laboratory applications. You can see an example in this bottom right corner where the tape is being used to hold on a temporary closure, that silver foil. And of course, the tape must also be able to stick to these surfaces as well, like glass or foil or other surfaces that might be used in a laboratory application. Ideally, the tape adhesive should be as strong as possible when used on single-use wraps, because we're not going to use them again, so we don't have to peel the tape off before the wrap is laundered. It's just going to be disposed of. However, if it's used on reusable wraps or lab glassware, the adhesive must have a degree of peelability so that it can be removed after use without leaving any residues. I'm sure everyone who's worked in an SPD or a lab have seen those sort of tacky residues stuck on, for example, rigid containers, or even the carts that you push your loads into the sterilizers with, where people have put a bit of autoclave tape on, and then it hasn't peeled particularly well, and it's left a bit of adhesive behind. And when they are baked in a sterilizer several times, they are really difficult to remove. So similarly, the adhesive must not only stick when it's first applied, but also over many months of storage. And it should also stick when it's cold, so immediately after you've wrapped your instrument sets, but also, obviously, when it's hot in the steam sterilization cycle, which typically runs at 132 degrees C. So for the autoclave tape manufacturer, these factors present quite some challenges in designing the adhesion, the adhesive that would be used on the tape to enable it to stick to the many surfaces that are going to be used, and to be able to stick when it's cold, but also when it's hot. So if we now look at the standards which apply to sterile processing departments, so these standards require that unprocessed items should be clearly identified from process packs. And if you look in EN ISO 17665, it states that a system shall be specified to ensure that processed and non-processed items are clearly differentiated. Now, in a industrial setting, this might involve segregation of loads. So you might have a double-ended sterilizer where non-sterile loads go in, and at the other end, the sterile loads come out. So that is a segregation by space. You might also have track and trace systems, so some kind of electronic means of identifying which batches have been put through the sterilization process. But of course, in the hospital SPD, the easiest and most obvious way of differentiating processed and non-processed items is through the use of an indicator tape, or also labels, and rigid container locks are also available that will contain a process indicator. Now, failure to use this kind of approach can lead to non-sterile packs being used. And that, of course, is the last thing we want to happen, because it puts patients at risk of getting infections or worse. And this still happens. This problem still occurs, and the popular press and sometimes the scientific literature prints stories of incidents in which a surgeon has used surgical instrument sets which have not been sterilized. Here's an example published in 2014, happened in Minnesota hospitals, and the surgeon inadvertently used non-sterile instrument sets. Really, it's an unforgivable incident, bearing in mind that several checks should take place before an instrument set is released from the SPD, excuse me, and then used in the OR. But it still does happen. So in fact, both the sterile processing department and the nursing standards of practice discuss this matter of release of non-sterile sets into use. And if you look at the WHO surgical safety checklist, which is universally adopted in many countries, This checklist states the actions that should be taken by the OR team before a pack is put into use. And one of the statements is that the OR team should check the sterility of every pack. And that includes the external and internal sterility indicators. And these will obviously give you a colour change. But this in turn relies on a very distinct, clear and unambiguous colour change on the indicated tape. Now, exploring this further, again, if you look at the WHO surgical safety checklist, this is an image of the actual checklist. It's pretty straightforward. It's just a tick box. But it has been shown through research that introduction of this simple checklist can significantly reduce both the morbidity and mortality of surgical procedures. So it is a worthwhile practice to adopt. And if you look in the checklist, you can see that in that central column near the bottom, there is a couple of tick boxes, and one of them is, has sterility, including indicator results, being confirmed? And the way in which the OR team would interpret this is to look at the colour change on the indicator tape that's holding the pack together. Now, clearly, many national and international guidance documents also talk about the use of indicators, chemical indicators placed in the centre of instrument sets, and it should be obvious that an indicator placed on the outside of the pack doesn't really give you any information about what's happened in the inside the pack, and so the use of internal chemical indicators is also valuable to the OR teams, because they can then see that sterilant has penetrated through the packaging and into the complex instrument sets located within the pack. So checking the sterility of every pack would often involve both making sure the indicator tape has changed colour, but also that any internal indicators present have also changed colour and indicated the penetration of sterilant into the pack. So let's now move on to standards for autoclave tape itself. Well, believe it or not, there are no internationally agreed standards specifically written for autoclave tape as a whole. EN ISO 11140 Part 1 describes the performance requirements for the indicator ink, which is printed on the autoclave tape. But this does not extend to cover other attributes of the product, such as how well it sticks to surfaces. I should point out that the British Standards Institute published a standard some years ago, 1997 now, which did actually discuss tests for adhesion, along with tests and requirements for the colour change on the indicator tape. Now, if we look at the specific requirements for type 1 process chemical indicators, and this is what these types of indicator are that are printed on the surface of autoclave tape. They are type 1 process indicators according to the definitions in EN ISO 11140. Then this document covers 4 main areas. The first is the nature of the colour change for the indicator ink printed on the tape. The second relates to the transfer of the ink to other surfaces which may come into contact with the ink. And as you can imagine, packs will often touch each other both before, during and after sterilisation, and there must be limits on the transfer of ink from the autoclave tape onto other surfaces which it might touch. The third relates to the labelling and support material which should be supplied with the tape. including the instructions for use, which must contain, and most importantly contain, the actual information about the colour change that the tape undergoes. And this is something which is often not adequately communicated to the OR teams, particularly if a new tape is introduced with a different colour change. Most autoclave tapes might go from cream to black, but there are some which go from a red colour or a green colour to a darker green or a black colour. And of course, this can be confusing to end users if they haven't been told that the new tape you're going to use has a different colour change. And the fourth requirement relates to the labelling requirements of the individual rolls of tape. So if we look at this in a bit more detail, then this table attempts to summarise what I've said. So if we look in the requirements for the standard 11140 Part 4, then first of all, the tape core, as you all know, the autoclave tape will be wrapped around a central core, which is usually made of cardboard, and the word steam should be marked on the inside of the core to clearly indicate that this is autoclave tape and it's not tape for another process. The tape core should also be marked with type 1 or class 1, this being the indication that it's a process indicator of type 1. The tape core should be marked with a lot code, an expiry date, and the manufacturer's name. And this is all for purposes of traceability. So if at some stage in the future the manufacturer would need to do a batch recall, then obviously he needs to know, or the user needs to know, which rolls of tape belong to which batch. And obviously the presence of an expiry date will indicate to the end user that the tape has gone beyond its useful life. One of the requirements of this standard is that the colour change that occurs should be clearly observable, and it should be either from a light to a dark colour, a dark to a light colour, or it should be from one colour to a distinctly different colour. So this is so that users can clearly identify processed from non-processed tape. And that is very important when end users are trying to interpret whether or not the pack has in fact been through a process. There's also a test for offset or transference, and this describes a method for determining if the ink will lift off the surface of the tape and transfer to another surface. Because obviously, if you have a sterilized pack and some of that black ink transfers to another pack, then that is not only unsightly, but it could create some confusion with the end user. Similarly, the ink should not transfer. If you imagine on a roll, the ink surface is in intimate contact with the adhesive surface by the nature of the fact that it's rolled up on a roll. So the ink should not transfer onto the adhesive layer above it, so that you don't then get some weird colour changes occurring when the tape is actually used. So let's now consider tape adhesion. Well, tape adhesion before and after autoclaving is more or less describing the adhesive properties. So peel strength is describing the adhesive properties of the tape. And it determines how well the tape sticks to a specified surface, which might be, for example, a sample of flexible wrapping material. Now, as I stated earlier, each sterile barrier system will have different surface properties, and the tape will interact with that surface in a different way. A good quality tape should stick well to the majority of wrapping materials that are going to be used after application by moderate finger pressure. So you shouldn't need to put the whole of your body weight on the tape in order to get it to stick. The tape should also stick well and remain adherent before the pack is autoclaved, which should obviously be as quickly after application as possible, but generally it might be up from 30 minutes to an hour before the packs are sterilised. And the tape should remain adherent during the autoclaving process, so the pack remains intact, particularly during the different pressure and temperature transitions that are going to occur during the sterilisation process. And the tape should also remain adherent after sterilisation, but importantly, it should remain adherent for many months afterwards. Some of these packs will obviously be used within possibly a few hours or a day of sterilisation, but others might actually be stored on a shelf for several days, weeks, or even months before they're used. And many adhesives will age during storage periods, and that aging process should not inhibit the adhesive properties of this tape. So let's have a look at testing of autoclave tape. The results that I'm going to show you in the next few slides were taken from a study where a number of individual commercially available tapes were tested. So what we're going to look at is the adhesion to a surface before and after autoclaving, adhesion during autoclaving, and then the colour change characteristics of the tape before and after it's been sterilised. So let's have a look at tape peel strength before and after autoclaving and how this would be typically tested in a laboratory situation. So in this first test, 1 foot lengths of tape were applied to one of several different wrapping materials, including the paper side of a paper film pouch, crepe tray wrap, non-woven tray wrap, non-woven Tyvek bags, surface modified non-woven tray wrap, and then a reusable tray wrap material. So several layers of the tape were removed from the reel to ensure that we were using fresh tape. And then 1 foot lengths were cut and applied to the surface. And then a roller with a 5 kilogram weight was rolled over the surface to replicate moderate finger pressure. Now, this is a standardized method of applying a defined downward pressure on tapes that you're testing for adhesion. So after application, the samples were left to cure for 30 minutes. This was judged as the minimum time between the application of a tape and when the autoclave process would be carried out. And of course, during this time, the adhesive would bond to the surface and begin to cure. Samples were then placed between layers of textile material to represent real-time use, and then exposed to a steam sterilisation processing cycle. Samples were then stored for up to 4 weeks before retesting in a post-autoclaving adhesion test. So the adhesion of the tapes before and after autoclaving were then determined. So this is the method which would be used typically to determine the force required to peel a tape from a surface. So this adhesive strength was tested using an instrument called a tensile testing apparatus, and you can see it in the right-hand picture. So in this device, a tab of tape was secured in the upper jaw of the instrument. You can see that highlighted by the yellow circle in the top of the picture there. The bottom part of the wrapping material was secured in the lower jaw of the apparatus, and again you can see that located in the bottom of the picture, identified by the yellow circle. The tensile testing machine was then activated, and it slowly started to pull the two parts of this assembly apart. And whilst it was pulling them apart, it was measuring the force that was required to pull the tape from the surface of the wrapping material. Now, this force can be expressed in different ways, but for the purposes of simplicity, in these tests, it was expressed as the kilogram, the equivalent kilogram weight that would be required to peel that tape from the surface. Now, this slide is an example of the kind of graph that you would record from the tensile testing machine. And you can see on the left-hand side of the chart is the peel force, and then the x-axis, the horizontal axis, is showing you the time taken to peel the tape from the surface. And you can see that it's quite a noisy signal, and this is quite typical of tape, because as you can imagine, as the tape is peeled from the surface, it will hold and then suddenly give, and then hold again and then give. So it's not a flat continuous process. But of course you can calculate the average peel force excuse me, from that signal. If we look at the results of these peel strength tests, this slide is quite complicated, so let me try and explain it. It's showing you a summary of all the peel force measurements made during these tests. Each drum represents a different manufacturer's autoclave tape, and each colour segment within the drum represents the adhesion on a different wrapping material. The upper drums represent the peel force before autoclaving, and the lower drums the peel force after autoclaving. So let me just make some simple observations. In all cases, the peel strength of each tape was lower before than after autoclaving, which is ideally really what we want to observe. We want to know that the tape will cure a little bit after it's been applied, and during the autoclaving process that it will form a good solid seal with the packaging materials for subsequent storage. It is also clear, as shown by the height of each drum, that some tapes have an overall better adhesion to surfaces than others. So if we look at this fourth set of drums from the left-hand side, then you can see the overall adhesion was much lower with that particular product than, for example, the very final drum on the right-hand side, which has very high adhesive properties to all surfaces. It can also be seen that none of the tapes adhered particularly well to the reusable non-cotton-based material. And it should be noted that this had a very shiny surface. That's the very top blue bar on all of the columns. It's the Protex reusable wrap. So you can see that because they are very thin slices, the peel strength was relatively low. So the tapes were not sticking particularly well to that material. And as I say, this is because it had a very shiny surface, and so it was difficult for the tapes to grab onto that surface. So let's now have a look at tape adhesion during processing. So the purpose of this test is to assess the ability of the tape to remain intact during a sterilisation process. And in this test, it's often called a bundle or pack popping test. And we attempt to illustrate the capability of the tape to hold the packs together during the sterilisation cycle itself. And this is a measure of the tape's ability to work when it's cold, but also when it's hot and subjected to moist heat conditions and big internal pressures. 2 points I must note is that if the tape pops then the pack cannot be regarded as sterile. So this is an undesirable consequence of poor adhesion, because if packs pop open during sterilization, it means they have to be reprocessed. The second is that the video I'm about to show you is not really a scientifically developed test, but it is merely used for illustration purposes. So don't draw too many strong conclusions from the results. Well, a standard pack was prepared, which consisted of two stainless steel bolts, which were wrapped in a textile material and then placed inside a peel pouch, which was then sealed. So it effectively created a sealed space. This was then wrapped in the non-woven material of choice. And the idea behind the test was that during steam entry, these stainless steel bolts would create condensate, which would be soaked up by the textile cloth. And being sealed inside a pouch, this creates a sealed volume. So when the pressure inside the sterilizer fell, the condensate would immediately flash into steam, pressurizing the sealed pouch like a balloon, creating an outward force on the tray wrap, which was secured by a small piece of tape. So this is the sterilization cycle that was used, and these packs were held together by a 1-inch square piece of tape. So it's a really challenging test for a tape's adhesive capabilities, and obviously in real use a sterile processing department would typically use much longer lengths of tape to hold their packs together. So let's now look at the video, which I hope will begin to play. There we are. Sorry, there's a bit of delay there. So you should be able to see this video, and this video was actually taken from inside a sterilizer. So there is a window in the sterilizer. And if you look at the right-hand side of this video, you will see some graphics. First of all, there's a little stop clock showing you the time into the cycle. There's a pressure gauge in the middle there showing you the pressure inside the chamber. There's a little diagram below that with a red dot showing you how we're progressing into the cycle, and there's a little graphic at the very bottom showing you the removal of air by vacuum or the entry of steam going into the chamber. So I'll just let you watch this video as it goes along. So you can see that already in that right-hand side, one of the packs has already popped open. We're now blowing steam into the chamber, and then we're evacuating it again. And again, as a result of those pressure changes, one of the packs has popped open. And now we're starting to draw a vacuum. And that particular tape has given way at this point in the cycle. We're now pressurizing the chamber again with steam, and then we will evacuate, and you can see those packs ballooning, and some of the tapes are not able to hold that force which the ballooning creates. Again, we're going through a sequence of evacuation and steam admission. So we're now going into the actual sterilization phase. So inside the chamber is relatively quiescent. We're now at 134 degrees at about 3 bar absolute pressure in a steam environment. And you can see that we've speeded this section up by virtue of the fact the clock's zooming around. We're now going into the drying phase, so we're dropping the pressure inside the chamber, and you can see that as that pressure falls, the packs begin to balloon as a result of the condensate inside them flashing off, and it obviously takes time for the steam to permeate through the wrapping material. So you can see in this graphic the tapes which were able to hold that force in that wrapping material in place, and then those which were not able to. So if we now go on to the other slides, then you can see this slide is illustrating the points in the cycle when the tapes that did give way gave way, and so you can see that for some of the tapes they did not hold the pack together for very long into the cycle at all. Well, let's now consider the tape colour change. Now, EN ISO 17665 requires, as I mentioned earlier, a method for differentiating processed from non-processed packs. And the application of a simple type 1 chemical indicator is an easy way for the hospital sterile processing department to achieve this. And in addition, I also mentioned that the OR teams, if they're using this surgical safety checklist, would use the tape as one of the indicators to judge that the pack is sterile. And it makes sense that the indicator colour change should be very distinct, unambiguous, and the start and end colours should be very different. So let's consider the colour change during sterilisation. Now, one of the popular misconceptions is that autoclave tape or any chemical indicator-based product will suddenly change colour when it's exposed to a certain temperature for a certain length of time. Well, this is not really true. These indicator tapes don't act like a light switch. 1 minute the light's on and then immediately you turn it off, you get a dark colour. The colour change will actually occur gradually and at a speed which is dependent on the temperature of exposure. So the higher the temperature, the quicker the ink changes to its final colour. But that colour change is not instantaneous. I often got questions from customers asking, well, at what temperature does the ink change colour? Well, it doesn't. It changes colour at a speed related to temperature, and the higher the temperature, the quicker the colour. But it should be noted that the ink will eventually reach an equilibrium plateau colour, and this is called its endpoint. So when testing tapes, the colour change is normally established using a piece of equipment called a resistometer. And this is effectively a very small autoclave. It has a chamber capacity of about 20 litres. You can see this resistometer in the picture here. And the reason why it's small is so that you can control the conditions within the chamber very carefully. And you get a very rapid rise in temperature when steam is admitted. And similarly, at the end of the exposure phase, you get a very dramatic decrease in temperature. So you're effectively using what's called square wave heating of a square wave heating profile in that chamber. And that means you can establish very accurately the colour change characteristics of the autoclave tape. Now, obviously, normally these autoclave tapes are judged by observation, by visual observation, but you can also measure the colour and quantify the colour using a reflectance densitometer or spectrophotometer, which you can see in the top right-hand corner of the slide here. And this is actually measuring the extent of colour change which has taken place. So if you look at this slide, you can see a number of samples of autoclave tape from different manufacturers that have been exposed anywhere from 0 up to 5 minutes, 134 in a steam test vessel. And you can see from this picture the sort of how the autoclave tapes will change colour as they are exposed to different lengths of time of exposure. And we can also quantify those colour changes using this densitometer. And if we plot the optical density of the measured colour against time of exposure, you will get a typical set of curves like this, which are shown on this chart. And it should be immediately obvious that tapes which give a big colour change from the start colour to the end colour are easier to interpret than those which don't give a particularly good colour change. And we can illustrate this further in this graph here, where you can see the drums are shown on the axis. The small segments at the very bottom of each drum are the optical density of the starting colour. The middle sections of the drums are the optical density of the end colour, and then the very top drum, the grey drums, are the difference. And so it should be obvious that the bigger the difference, the bigger that drum, the easier it is to interpret that colour change. So you can see in this diagram that left-hand drum right up against the y-axis exhibits a very good, strong colour change. And then the ones further to the right exhibit a less obvious colour change. And in some cases, some users might misinterpret those colours. So let's draw some conclusions. On the surface, I think you would all agree that autoclave tape seems a simple utility product, which is hardly considered by the practitioner. However, as you all appreciate, autoclave tape plays a vital role in preventing unprocessed surgical sets being used, and therefore it protects patients against infection. And not all autoclave tapes are the same, as I've shown with some of these comparative results from this laboratory study. So adhesive properties ensure good adhesion to many different surfaces, and this ensures that wrap packs remain intact. And of course, colour change properties ensure a big difference in colour between unautoclaved and autoclaved packs makes for easy interpretation. So on that note, I'll thank you for listening to the presentation, and I'll open the floor up to any questions that you might have. Thank you.
Thank you, Dr. Kirk. That was incredibly fascinating. We did get several comments about the video, if the video could possibly be made available in the speaker notes. So we'll talk offline about that, and we'll see if we can add that to it. But it was really fascinating to see inside the chamber as those things were happening. We did get some questions in, so let me start with this one. Do you look at the adhesion qualities immediately after removal from the sterilizers to see if there were issues during the cooling process? Or is it assumed that if there is good adhesion at 4 weeks, the tape was not affected by the cooling process?
Well, that's a very good question. Yeah, and the way the study was set up was basically to test the adhesion before and after autoclaving. And the way I did the study, I decided that it was probably good to test the adhesion after a 4-week storage period to try and assess whether or not the tape was becoming less adhesive, or in many cases more adhesive, because of this curing process that took place. So that is a piece of data that is not available. I did not test the tapes immediately from after taking them from the autoclave. It should be borne in mind that that would have been very difficult to control because, of course, I would have needed to run a whole series of different autoclave cycles. As soon as the tape came out of the autoclave cycle, I would need to get it in the tensile testing machine and start peeling the tapes apart, and trying to make sure that was carried out at exactly the same time after processing probably would have been difficult. There probably would have been at least a 30-minute, if not longer, period. So that's an interesting question, and that data is not available.
All right, very good. There's like a series of questions that I would like to ask you about the amount of tape that's needed to close these sets. So in my years in sterile processing, I have seen technicians basically wrap the whole thing in tape, like wrap around it. I've seen them go 2 horizontal and 1 vertical all the way across the set. What is your opinion on the amount of tape that's needed, or how much is needed to actually like seal these sets for sterility?
Okay, well, that's a very good question, and there's lots of different elements to the answer to this. The first one is the less tape you use, the cheaper it is for you, because obviously the tape is costing you money, and if you have to wrap it round and round and round, you're going to use a lot more tape, and therefore it's going to cost you more to produce that individual pack. I think you need to use as little tape as is needed to keep the packs intact, and generally speaking, all that you should really need is maybe a 4 to 6 inch length of tape, and this again is down to the adhesion properties of different tapes from different manufacturers. Now, I know exactly the point you're making with that technician comment. I've visited a lot of SPDs in my time, and you talk to the technicians and say, well, why are you using so much tape? And they say, well, this tape just doesn't stick. But we have to use it because that's what the purchasing department has given us. So again, it's this problem that the cheapest tape in the long run is not always the least expensive for you, because if you have to use 3 times as much tape as for maybe a little bit more expensive tape because it has better adhesion properties, then these are the things that all need to be balanced up when you're making those purchasing decisions.
Yep.
From the point of view of sterility, the actual sterility of the pack is not down to the tape. The tape is keeping that parcel together. And as you know, the folds that are created during that packaging process are the effective sterile barriers. The tape is simply holding all those folds together so they don't fly open during sterilization and then no longer create that effective sealing element of the tray wraps.
Excellent. Yeah, I mean, just like we talked about earlier with the water quality talk, I'm going to take that little snippet and I'm going to play it for staff, because I've seen so many departments that just wrap and they have crazy amounts of tape going horizontally and vertically and just wrap that whole thing in tape. And it's really unnecessary. If you have good tape, it's 4 to 6 inches is really enough. You just want to be able to seal it. I did have kind of a follow-up question on that too, which was, and if you guys have questions out there, we didn't get very many questions in, I think because the presentation was so comprehensive. We didn't get a lot of questions in, but if you guys do have questions, you can click the Ask Questions slide. I'm going to highlight again for you guys. You can ask questions of Dr. Kirk. So the follow-up question to the amount of tape is, what kind of pressure do we need to put on it when we're sealing the tape down? Because I know I've really kind of tried to press it onto the wrap and kind of seal it on there. But I know some people just place it and they just put it on there and don't really put a lot of pressure. Is there a recommendation on the amount of pressure we need to put on that tape?
Yeah, I think all of these are what are called pressure-sensitive adhesive tapes. And essentially what that means is to get the adhesive to bind to the surface, you need to apply moderate pressure. You don't need to be an Arnold Schwarzenegger to get these tapes to stick. but you do need to apply a reasonably firm pressure, downward pressure with either your thumb or your finger, and that should be then adequate to get that binding process between the surface of the wrapping material and the adhesive on the tape. Now, the point in the presentation about some of these wraps have a surface modified surface which will not readily accept an adhesive on the surface. So for those, you may find you need to apply an awful lot more pressure to get that initial tack between the adhesive and the surface. Once the adhesive sticks to the surface, then it starts to interact with the surface and it will start to migrate into the surface and give you that strong adhesion. But for most wraps, just moderate downward pressure with a thumb or finger should be enough. Just laying the tape on the surface is not adequate. They are pressure-sensitive adhesives.
Pressure-sensitive adhesive. That's exactly what I wanted to hear. That's good to know. Let's see. Looking to see if we got any questions in. Not yet. I really think, honestly, Dr. Kirk, everything we ever wanted to know is already in that presentation, so I'm not sure there are a ton of questions. I just have one more for you, which is with the adhesion of this tape with, say, like a surgical technician that's going to open this package in the OR, the idea behind the tape is that it will break when you pull the tab on the package. Is that correct? So they never need to actually come in contact with the adhesive itself. I've seen technicians that actually will take their finger and like run it along the tape to break it, but doesn't that leave adhesion on their gloves, which could be a problem in the case?
Yeah, this is again one of these balancing factors where you need to have an adhesive that will hold everything together, but at some point there may be a necessity to have peelability when you apply a slightly greater force. And I think, again, it depends on the materials you're using, because if you're using reusable materials, then you don't want an adhesive that's going to leave a load of a tape which has an adhesive that will leave a load of residues behind, and because then that causes problems in the laundry. And so it's a case of balancing that peelability with the ability to hold the pack intact during the sterilization process.
I gotcha. All right, perfect. So that's probably all the time we're going to have for today. If you guys did have questions that we weren't able to get to, or you want to ask Dr. Kirk a question, his email address will be in the right-hand corner of your screen. So feel free to reach out to him directly if you need to. But thank you, Dr. Kirk. That was a really fascinating topic, really fascinating presentation on the topic of sterilization tape. Really informative. If you guys have, again, questions, send Dr. Kirk an email. I'm sure he'd be happy to answer them. And just as a reminder, there will be another 15-minute break before our next session. We're glad you're here, and we're going to see you back here in a little bit.
Thank you.